So our next example is actually not as hard as you might think. The only tricky thing about this example is that it involves two voltage sources. It's really the first time that we've ever seen a circuit that has two voltage sources. You know, if we had only one voltage source, I would think of that as the driving force in the circuit. In this case, it's not so apparent. Now, it's an 18 volt and a 6 volt source, so my guess is that the 18 volt is going to win. But you could kind of think of it as like a tug of war. Or in this case, what it probably is that the 18 volt source is genuinely a source, and the 6 volts is probably like a battery that's being charged. So what we're going to do is we're going to do a Kirchhoff's voltage law around the circuit to try to find out the direction that current is flowing. And then once we've done that, we'll be able to figure out which one of these is actually providing power to the circuit and which one is absorbing power. So Kirchhoff's voltage law going clockwise from the bottom left-hand corner, I'm going to encounter the negative sign first, then the positive sign, and then the positive sign. So when I write my KVL equation here, it's so nice that this just takes care of itself by just using the sign of whichever one we encounter first. It seems a little bit too easy to me that we don't have to give it any more thought than this, but that's the way that we write the equation. Minus 18 plus V sub AB plus 6 equals 0. And therefore we can write that V sub AB is equal to 18 minus 6, which is therefore 12 volts. And with one equation and one quick calculation, we've already solved half of the problem. Now we're asked to find I sub AB. You can see I sub AB as this current right here. It's actually the same current that's going around the entire circuit because there's really no other place that current can go in this case. So I sub AB is actually at all points in this circuit. We will encounter later on some other places where there might have been some branching that the I sub AB could do, but really we could have just labeled this as being I. But in this case, we can just say that I sub AB, by Ohm's law, we know the voltage across V sub AB, and we know the resistance. So this is going to be V sub AB divided by 3 ohms, which is 12 volts, divided by 3 ohms, which is 4 amps. And because 4 amps, well, and the 12 volts are both positive, this tells us that our original estimate, our original guess, as to the direction of the current and the polarity of the voltage were both correct. So we can see that current is in fact flowing clockwise around this circuit. That means that it flows into the negative terminal of the 18 volt source. So it's flowing into the negative terminal and flowing out of the positive terminal. And that means that it's raising its energy while it's inside the 18 volt source. So therefore the 18 volt source is in fact providing the energy for the circuit. On the other hand, it's coming into the positive terminal of the 6 volt source and coming out of the negative terminal of the 6 volt source. Therefore, it's lowering in energy as it goes through the 6 volt source. That means that it's providing energy to the 6 volt source. And so, I don't know if we should even call it a source, to the 6 volt voltage drop that appears there. And it does, in fact, look like the 6 volts is being charged by the 18 volts.